Hi everyone, really excited to be here today. My name is Justyna Lucznik and I'm the Group Product Manager for the Data Engineering and Data Science capabilities in Microsoft Fabric. So as you may know, we recently launched at Build with Microsoft Fabric. And so what we're going to do today is do a bit of a deep dive into the data engineering workload and just see what it's all about. Okay, so let's go ahead and jump straight in. So as mentioned, we launched Microsoft Fabric at Build, and Microsoft Fabric is basically our next generation data platform that brings together all of these different workloads ranging from data factory to data warehousing to data activator in a single unified platform. And what we're going to focus on today, as mentioned, is specifically the data engineering workload and seeing what basically Microsoft Fabric provides for our data engineers in terms of their end-to-end journey. And specifically, we're going to be talking about 4 things as we think about the data engineer in Microsoft Fabric. And we're going to go through each of these pillars, what they're all about, but generally the vision and the intention for the data engineer is to be able to transform their data at scale and build out a lakehouse architecture. So the first pillar we're going to jump into is talking about what it means to build a lakehouse for all of your organizational data and show you how you can get started with building lakehouses inside Microsoft Fabric in just a few clicks. The second pillar is really all about Spark. And Spark is the backbone of the data engineering experiences. It's what basically allows us to go and transform this data at scale. And we're going to talk both about the engine, the runtime, but also what sorts of admin controls we're providing for our users to ensure that they can use Spark in a way that's right for them. Now, in order to go and use Spark and build out these lakehouses, you're going to need to go and actually transform this data. And so for that, we provide you with awesome developer experiences. So we're going to look at the notebooks, we're going to look at our VS Code experience, at Spark jobs, and essentially we're providing our users with all the different tools they may need to do their data authoring. And finally, we're going to talk about how all of this data engineering workload is tightly integrated into the Fabric Foundation. And this is true for all of the workloads that we saw on that previous slide. And again, this is one of the kind of key integration and key components of the Fabric platform. Okay, so let's go ahead and jump in. And the first pillar we're going to talk about is the data lakehouse. So what is the lakehouse? Let's kind of take a step back and talk a little bit about what we have over here. So the lakehouse is actually an artifact in Fabric. That means just like you have your reports, your warehouse, your data flows, you have a lakehouse that you can go into your workspace and create. And the intention of the lakehouse is really to allow you to store, manage, analyze all of your data in a single location, and then ensure that that data can be easily shared with all of the different users who may want to consume that data in many different ways. So firstly, this is a flexible solution that allows you to handle all sorts of data, ranging from structured, unstructured, IoT data, event streams, whatever you might be bringing in, you can bring it into this lakehouse. Secondly, what we provide you is a built-in SQL experience. So every lakehouse automatically comes pre-wired with a SQL endpoint that just comes with this lakehouse. You don't have to do anything to set it up, and you can just leverage T-SQL on top of it. You can go and build out your views. You can write your SQL queries. You can even create visual queries, all on top of this lakehouse experience. And finally, Power BI also comes directly integrated into the lakehouse. And this is because Power BI now also supports direct lake mode, which basically means Power BI can natively read the Delta Parquet data that's in the lake, that the lakehouse is leveraging. And so again, you can kind of create your Power BI reports directly on top of the lakehouse with no setup necessary. So the lakehouse in Microsoft Fabric really eliminates that friction of collaboration and lets you go from the sorts of data engineering workloads, having that data in that unstructured way, transforming it, using SQL on top of it, and then building your Power BI report with really very minimal integration needs. Now, how do you actually get your data into the lakehouse? Well, here we're also providing our users with a variety of different capabilities that they can leverage. The first capability that you're kind of seeing on the screen over here is pipelines. So if you're working with massive amounts of data, you want to use something like the copy activity, you can just leverage and create a pipeline directly from your lakehouse. Your lakehouse becomes an output destination. You can go and bring your data from many different sources and just either bring the data as structured tables tables or just dump it into the lake portion, which is the files section of the lakehouse. You also have data flows that you can leverage for bringing data into the lakehouse. So if you want to use a more kind of a low-code ETL tool, you can leverage data flows and the hundreds of connectors that provides. And again, the lakehouse is provided as an output destination. Or if you want, you can leverage Spark, right? So if you want to go and write some Spark code, use notebooks, that you can absolutely use that to bring data into the lakehouse too. And we even make it really easy with things like a direct file upload. So in the lakehouse UI, you can just go and say, you know what, I just want to bring in some files from my local machine, and you can just leverage them to bring them in. Now, another capability that's really important in this lakehouse is something called shortcuts. So with the other capabilities we just talked about, you're actually physically copying the data into the lakehouse. But with shortcuts, you can actually refer to data that could be sitting in another lakehouse or another warehouse, or even in external storage, such as Azure Data Lake or even S3. And you can bring the data into the lakehouse without actually physically copying it. It just becomes a pointer to the data, and you're just creating virtual files or tables. And so that's another really great way of being able to work with data where you might have existing investments in your enterprise data lakes, or you have existing investments in Fabric, so you don't want to actually duplicate the data that's already in a lakehouse or a warehouse. And so shortcuts provide you this great capability of working with data in place with no data movement necessary. Okay, so an upcoming capability that isn't there yet, but we're working very hard on, we know this is a super important capability for all our users, is Lakehouse security. And specifically something that we call one security, where you define your security once and you can leverage this across the entire stack end to end. So for example, I could go into my Lakehouse, I could bring in all my tables, I could then go and apply security on top of that data. And then if I'm reading the data through the SQL endpoint, if I'm reading the data through Power BI, all of that security just carries through. And what's more, one security actually even works with external engines. So if I'm going in and let's say accessing the data through something like Databricks, that security again is going to be carried through. So one security just is a kind of a pervasive concept across the entire Fabric platform. So this is something that we're working very hard on. In the first release, we're going to bring object level security as well as file folder level security. And then over time, this is going to become more and more rich with row level, column level, in the coming increments. Another capability that is going to be coming very, very soon. I know I have public preview on this slide, but it's a matter of weeks before this is something you can start using, is Lakehouse sharing. So just like you can share, let's say, a Power BI data set, you'll be able to go into the workspace, you'll be able to select the Lakehouse that you want to share, you'll be able to specify the permissions. So do you want to share the entire Lakehouse? Do you want to share the SQL endpoint for reporting purposes? Do you also want to grant permissions through Spark? And so you'll be able to share the Lakehouse for consumption with people outside of your workspace. You don't have to grant them access to the entire workspace, but actually let them consume the data without that kind of direct access. And as an end user, if someone has gone ahead and shared that Lakehouse with me, I'll be able to basically access it through the OneLake Data Hub. So the OneLake Data Hub is our data discovery portal where you can see all the different lakehouses and warehouses and data sets that have been shared with me. And I can access that lakehouse, and then I can choose how I want to use it, whether I want to consume it through a notebook using Spark or through SQL or through Power BI. So there's that kind of direct connection with the end user. So let's go ahead and jump into a demo of the Lakehouse to see what these capabilities actually look like inside the product.
Today, we're going to take a look at how data engineers can leverage Fabric to build out a lakehouse architecture. In this scenario, I'd like to build a lakehouse for my organizational marketing data to share with the business. I'm going to start out by creating a new lakehouse artifact, going to give it a name, and then immediately land in the empty Lakehouse Explorer. The Lakehouse is a new experience that combines the power of the lake and warehouse and is a central repository for all Fabric data. I have a variety of options to bring data into the Lakehouse. I can simply upload files and folders from my local machine. I can use data flows, which is a low-code tool with hundreds of connectors, or I can leverage the pipeline copy activity to bring in petabytes of data at scale. Once my marketing data is in the lakehouse, Delta tables are automatically created for me with no additional effort. I can easily explore the tables, see their schema, and even the underlying files. I would also like to add some unstructured customer reviews to accompany my campaign data. Since the data already exists in storage, I can simply point to it with no data movement necessary. To do this, I'm going to add a new shortcut, which allows me to create a virtual table and virtual files inside my lakehouse. Shortcuts enables me to select from lots of different sources, including lakehouses and warehouses in Fabric, but also external storage like ADLS Gen 2 and even Amazon S3. Since my customer reviews are actually in S3, all I have to do is select it as a source, specify the data's location, and populate all of my account information. On the next screen, I can give my shortcut a name, and that's it in terms of setup. Within seconds, I can see a shortcut created in the Files section, which is the messy, unstructured data lake portion of the lakehouse. I can now explore the data in the lakehouse and even open up the PDFs, despite the data still physically being in S3. Now that all my data is ready in the lakehouse, there are many ways for me to use it. As a data engineer or data scientist, I can open up the lakehouse in a notebook and leverage Spark to continue transforming the data or build a machine learning model. As a SQL professional, I can seamlessly navigate to the SQL endpoint of the lakehouse, where I can write SQL queries, create views and functions, all on top of the same Delta tables. As I write a quick SQL query, I get results back instantly without needing to move any data. Finally, as a business analyst, I can simply navigate to the built-in modeling view and start developing my BI data model directly in the same warehouse experience. After adding relationships and measures to my data, I can generate a Power BI report in a single click. As I build out my report, I get amazing performance thanks to Power BI Direct Lake Mode. With Direct Lake Mode, Power BI can natively read the Parquet Delta format stored in one lake, meaning, again, no data was duplicated in the process. To conclude, in Fabric, data engineers have a frictionless experience building out their enterprise data lakehouse and can easily democratize this data for all users in the organization.
Okay, so now that you know all about the lakehouse, let's talk a little bit about the Spark engine. And we're going to start things off by talking about the runtime. So every single Fabric workspace automatically comes pre-wired with a runtime by default. And this runtime contains Spark, Delta, Python, and in our case, for the first runtime that we released, we have Spark 3.3.1, Delta 2.2, and Python 3.10. And in public preview, we have one single runtime, but what you're going to see is every couple of months, we're going to have a pretty regular cadence of updating things, releasing new runtimes, so that users will get a default runtime, but they can also choose which runtime they want to use. And with this runtime, what this basically means is I can go and, as you can see here, create myself a new notebook. I can start writing some Spark code, and automatically it's going to use the default runtime that's defined inside my workspace. Now, Delta is a key component of the runtime, and you're going to hear us talk a lot about Delta across the entire Fabric vision. Delta is what enables us to essentially have this one copy architecture where I can have Spark, SQL, Power BI, all of the different Fabric engines basically work with the same copy of data. And what you're going to see is all the Fabric artifacts automatically write Delta with V-order optimization. And that basically provides great out-of-the-box reporting capabilities with Power BI with basically great performance. Now, we also know that not everyone has their data in the Delta format automatically. And so one of the capabilities that we're adding into the Lakehouse is what we call load to table functionality. So here you can see I've got some CSVs. I can right click on them. I can choose to load them to a Delta table, give my table a name, and it's going to automatically just appear as a table in this table section. And so you're going to see us investing a lot more in these sorts of capabilities in the future. You know, we have our kind of first starting point. Stay tuned for the July update for Fabric. You're going to see already some new capabilities coming in here. Basically, we're going to just make it really easy for customers to bring the data into the Delta format so they can have it synchronized across all the engines if they don't have it in this format already. Now, one of the key components you're going to hear us also talk about a lot with Fabric is performance by default. So what this basically means is we want to ensure that we can provide as much performance as we can out of the box without customers needing to necessarily go and tune these engines, so that things are basically easy to use and you don't have to be an expert in Spark or SQL to be able to get started and leverage Fabric. So some of the things you're going to see that are already in the product is basically query optimizations that are just built into the runtime. So for example, one thing we have already there is partition caching. So we automatically store filtered partitions in a session level cache. So we can kind of reduce the number of calls to Metastore. We have some exciting things with being able to do more performant cross joins by being able to package multiple scalar subqueries into single plan. But some of the capabilities that we're really excited that are coming soon is things like auto-tune, where as you run a job, and if this job is scheduled and is running on a regular basis, we can automatically analyze the job and we can tune various parameters. Right now we're tuning 3 parameters, which is number of partitions, broadcast join thresholds, and partition sizes. And what you're going to basically see is that over time, these jobs are going to become more and more performant. Like you can see over here, that the time for running as we do more iterations basically reduces. And so auto-tune is something we have in private preview currently, and it's going to be coming soon to Fabric as well. Now, another important area of performance is, of course, startup times. We know how painful it is when you want to go into a notebook and start working, and it's taking a couple of minutes before you can actually start leveraging, before you can start writing some code. So what you're also going to see in Fabric is that every single workspace, not only does it get a default runtime, but also gets a default starter pool. And the starter pool is basically kept live. This is something that we do behind the scenes. We keep these starter pools live with certain default configurations that we define. And that means that we are able to provide you with a Spark session within basically up to 15 seconds is the kind of performance you should be seeing. So again, we really want to have that great 5x5 experience where you can come into a notebook and you can just automatically start writing your Spark code with these sessions starting almost instantly. Now, another area that we're also investing in, and this is coming very, very soon. It's not quite out yet, but it will be coming very soon to the public preview, is high concurrency mode. And what this basically enables you to do is to share a Spark session across multiple notebooks. So if I've already, let's say, have a notebook running and I go and create a second notebook and I want these notebooks to share the same session, I can just attach the second notebook to my existing session. This has a couple of awesome perks. Firstly, I reduced that 15-second startup to pretty much less than 5 seconds because that session is already up and running. Secondly, I can also save on costs because it means I don't have to have a separate Spark cluster set up. I can just use the same Spark cluster across both of these different sessions. And what you're going to see coming soon is we're going to be expanding this outside of notebooks and also allowing you to have high concurrency, for example, in pipelines as well. Now, from an admin perspective, we also, of course, want to give our users a lot of controls over the sorts of Spark pools they may want to create. So whilst we do provide you with the starter pool that has great, let's say, defaults, as an admin, you can come in and say, you know what, I actually want to create my own Spark cluster. I want to choose things like the number, like the node size, number of nodes, executors, whether auto scale is turned on, dynamic allocation of executors. And what you'll actually notice as you're setting up these custom pools is they actually start all the way from a single node. So that means that you're now able to run these sort of smaller jobs, minimize spend, which again we know has been a big ask. So you can basically create all the way from a single node within Fabric. And with a capability that's not out yet, but it is coming soon, is also the option to keep these clusters, these custom clusters live. So just like your starter pools are live and you get these great startup times, if you've defined your own custom pool, you will in the future be able to choose to keep that live as well to be able to benefit from greater, faster startup times too. Now, in addition to being able to define custom Spark configurations, we also allow users to customize their workspace settings through things like library management. So we have this workspace level library management where you can go and define all the public and custom libraries that you want to basically leverage, and then all of your notebooks and Spark jobs in the workspace will automatically leverage these. As mentioned, you can select the default runtime as well. And in the future, we're also going to allow you to govern policies based on Spark properties. And users will basically be blocked from defining new properties that might conflict with the policies that the admin has defined. Finally, another thing that's coming soon that's not there today to give users even more granular control is an environment artifact. And so what environment artifact basically is just like you have the lakehouse and the report, you'll be able to define a new environment inside your workspace. In here, inside the environment, you'll be able to define all of these libraries. You'll be able to change the runtime. You'll be able to say, I want to actually attach this environment to a different Spark pool that I might have defined. And then I can go into my notebook, for example, and say, hey, notebook, instead of using the default runtime or the default settings that are in my workspace, actually use this environment instead. And so within a single workspace, you'll be able to mix and match which notebooks, which Spark jobs use, which settings, libraries, hardware. So just giving you a lot more granular control of what you can do within the workspace. Okay, so that concludes some of the Spark capabilities. So let's jump into a demo of the admin experience so you can get a better feel for it as well.
Let's take a look at how an administrator can configure a Spark environment for their data engineers. I'm starting out in the Capacity Admin portal, where I can now access the Spark Compute settings for data engineers and data scientists. Opening up the Spark Compute option, I can set a default runtime and default Spark properties. I can also turn on the ability for workspace admins to configure their own custom Spark pools. I'm now going to navigate to the marketing workspace, which I'm getting ready for my data engineers. The workspace comes pre-wired with a default Spark pool that all notebooks and Spark jobs inherit from. We can view and modify this pool by navigating to the workspace settings and drilling into the Data Engineering and Data Science tab. Here I can modify things like the default libraries that come with the workspace. For example, I can search for the word cloud library and choose the version that I want. I can also add libraries from Conda and from YAML files, or upload custom ones directly. Navigating to the Spark Compute settings, I can see that my workspace automatically comes with a default starter pool, and I have full transparency of all the pool details. Without needing to set anything up, all notebooks and Spark jobs can leverage the starter pool to run their jobs. In this case, I would actually like to run some small test workloads, and so I'm going to create a new default pool. I'm going to give the pool a name, and select a small node size and turn autoscale off. I can now set my Spark pool to always run with a single node for my test workloads. Finally, I'm going to reduce my executor upper limit and create the pool. Our workspace admin also has the ability to change the default runtime and modify Spark properties. Now that everything has been set up, I can save my workspace settings. Any new notebooks I create will now automatically use a single node Spark along with the selected runtime, libraries, and Spark properties.
So next, let's take a look at the developer experience to see how users can actually write their Spark code inside Microsoft Fabric. And the first experience we have for our users is, of course, the notebook experience, where users can benefit from capabilities like real-time co-authoring so that multiple users can author the notebook at the same time. You can leave comments in the notebook for others to see. The notebooks have very tight lakehouse integration, so you can just drag and drop your files and tables from the lakehouse into the notebook and automatically get code snippets. You can benefit from the notebook auto-saving, lightweight scheduling if you just want to run and refresh, or you can go ahead and actually put it into a pipeline with full-blown pipeline integration. Now, users are also able to leverage Python and R libraries and actually just install them directly in line using commands like pip install. And you can also benefit from some more advanced notebook capabilities, such as the ability to reference notebooks and other notebooks, and get snapshots for easy troubleshooting. Now, coming soon, in just a little bit of time, is also something called the Notebook Resource Folder. And this is basically the ability to just store more like dependency files, helper files, maybe source code, images, text, directly as a part of the notebook. So you can just upload your files and then again just drag and drop them in, like you can see uploading something like an image or a Python module. So making it much easier to just work with kind of these ad hoc assets. We also have notebook monitoring, so you have full built-in inline monitoring experiences. So every time you run a install, you can go and actually see the logs and see how the Spark job is doing. And we also have Spark advisors that analyze the code, analyze the Spark executions, and provide advice to basically help avoid common mistake and also try and promote best practices. We've done a lot of work to actually go through all of the different error types and error classifications and try and classify about over 150 errors. So again, as kind of the Spark advisor is running, we're hoping that the errors that users are getting are just a lot easier to parse through. Now, a pretty exciting capability for users who are maybe, who enjoy more kind of low-code capabilities is Data Wrangler, which is built directly inside the notebook, and you can launch it on top of all of the different Pandas data frames right now. And then you can basically go in through and be able to carry out data transformations, do data cleansing, such as dropping columns or one-hot encoding, all within the UI, and this automatically generates Python code for you, which you can add back into the notebook, so you always have, all the reproducibility of what you just ran. Coming soon, we're also going to be adding full Spark support for Data Wrangler, meaning that you'll be able to work with Spark data frames as well, and we're also looking to add some OpenAI integration to this too. Now, on the subject of data exploration, we're also going to be revamping a lot of the notebook capabilities with rich data frame and visualization displays. So you'll be able to do things like view built-in statistics and get a good understanding of your data set. So all of those experiences are going to be improved in coming months. And we're also exploring how we can more natively integrate notebooks with Power BI for being able to give users other options for doing your data exploration. So for example, being able to open up Power BI visual or even maybe a full report from the data frames that you have inside your notebook. So there's some interesting things that we're exploring over here. Now we're also working on adding Copilot integration directly into the notebook. And so the idea over here is you'll be able to leverage Copilot without needing to do any configuration beforehand. It's just going to be built directly into the notebook. And there's a lot of different capabilities that we're investing in. Firstly, starting from magic commands, where you can just write things like %chat or %code directly into your notebook cell and get back natural language responses or automatically code generated depending on what your prompt had said. We're also working on leveraging creating code shortcuts to accelerate common activities. So basically, if I have, let's say, to run as you can see, a cell here, I can go and fix the error automatically in the line with the help of Copilot, or maybe even do things like explaining or refactoring the codes, just built-in shortcuts for being able to really easily work with the data. So we have, exciting Copilot integrations, and the important thing to note here is these are all data aware, so they're going to be aware of things like the lake houses you're working with, given data is such an integral part to all of Fabric. Finally, another upcoming capability that we're pretty excited about is how we can leverage notebooks to be more of a storytelling mechanism. How can we start exposing notebooks through things like Fabric apps? So just like you can have an app with reports and dashboards, imagine you could add another tab to it with something like a notebook page, which is more of a read-only consumption mode, where you could play around with sliders, maybe run a simulation, so be able to, have more of an interactive experience, but it's just distributed in the same way all of your other content in your organization is. Okay, so this gives you a little bit of an overview of some of the dev experiences. Let's take a look at a demo to see how it all comes together.
In this demo, we'll dive deeper into a data developer's authoring experience in Microsoft Fabric. In this project, I'm collaborating with my colleagues on a predictive model built on top of the marketing data in the Lakehouse. I can see Pira has the notebook open, and I can view his code updates in real time inside the cell. To get started, I'm going to install an ML library I need for my project. Thanks to the built-in live pools, my Spark session starts in a matter of seconds, and I can immediately start being productive. I can now drag and drop my campaign table from my Lakehouse, and a code snippet gets generated for me immediately. As I run my cell, I can leverage the inline monitoring to monitor my Spark job and make sure everything is running smoothly. I can get a preview of my data and use the built-in charting capabilities to explore things and even adjust the charts around for better insights. Next, I can use the display summary function to get a quick overview of the quality of my data, looking at data types, missing values, and summary statistics. I can now leverage Spark to do some additional data cleansing, for example, getting rid of the missing values. Users can also use custom libraries to explore their data further. In this case, we'll plot some box plots to look at data distributions of call durations, broken out by job types, and campaign outcomes. The notebook has a built-in resource folder, which makes it easy to store scripts or other code files I might need for the project. I'm going to drag and drop the top feature selector Python script that my colleague created, and I can get a quick overview of the functions it supports. I can now use the top feature selector function to identify the most important features for my model. I can leave my colleagues a comment to the notebook cell, letting them know about my progress. All this time, my notebook is getting auto-saved without any involvement needed from me. I'm now ready to train my machine learning model. After some experimentation with a variety of different model types, I decide to use a logistic regression for this project. Finally, I can plot an ROC curve to evaluate my model's performance, and I can easily store it as an image in my notebook resource folder, so that my colleagues can easily check it out as well. To conclude, Fabric provides me with a rich developer experience, enabling users to collaborate, easily work with their Lakehouse data, and leverage the power of Spark.
Now let's also talk about some of the more pro-dev experiences that we offer. So we know not everyone wants to work inside a notebook. What you'll find in Fabric is we also offer native VS Code integration, where you can just launch VS Code directly from inside your notebook experience. We have an extension where you can navigate through your workspace, work with your notebooks, your Spark jobs, Lakehouses directly inside the IDE. You can run and debug your notebook cells, or your standard batch jobs. And you can work with all of this directly against a remote Spark cluster. That means you can be working in VS Code locally on your local machine, but you can be connected to your Spark clusters in Fabric and running your jobs against them, but benefiting from the full ID experience with debugging and so on. Now, in a couple of months, what we're working on is also working in a fully remote way. So you can actually work in VSCode.dev and just launch the online editor, have your changes reflect back in real time. So you'll both be able to work locally as well as fully remotely as well. And the final experience that users can also use is if they want to just do their authoring completely offline in their own tool, and all they want to use Fabric for is really just to submit these jobs, they can do that too. So they can come in, they can create a Spark job definition, they can submit their files, such as their .py file, R, jar files. They can add all their references, command line arguments. They can even specify Lakehouse references, and they can just submit these jobs, run them. They have their monitoring experiences. They can run them on a regular basis. And what's more, one thing to highlight with the Spark jobs is they also support retry policies. So with retry policies, what that means is that users can just run these jobs indefinitely. You have Spark streaming jobs basically that can run, and the jobs never have to get restarted because they have that kind of retry policies enabled. Okay, so that was a little bit of just some information about the prototype experiences. Let's actually take a look at demo of the VS Code experience that we have in Fabric.
As a data engineer, I want to work with some of the marketing data in my lakehouse. Since I prefer working in IDEs, I can make use of the native Notebook VS Code integration and open the IDE in a single click. I'm instantly navigated to VS Code and prompted about opening up the Synapse VS Code extension. My marketing notebook is automatically downloaded, opened up, and ready to use. I can easily browse all the notebooks, Spark jobs, and lakehouses in my workspace, and interact with the notebook I was previously working on in the browser. I have the option of working with my notebook locally, or I can easily connect to the remote Spark cluster in Fabric to leverage the Spark pools I'm already using in the service. I can now start my work in VS Code and run my notebook cells to continue iterating on my project and can seamlessly see the output of my run. In this next step, I can add a breakpoint to my code and leverage all the great debugging capabilities of VS Code for my project. As I debug the cell and hit the breakpoint, I can work with my notebooks just like any other regular local Java or C# script. When I hit the next breakpoint, I can inspect my data frame object in the local call stack on the side and see all the columns, data types, schemas, and more. I can also, of course, keep working in the notebook and adding my own code cells. In this case, let's go ahead and save our cleansed data as a new table in the lakehouse. In the workspace view, we can navigate through the lakehouses available, expand out the marketing lakehouse, and see all the tables we're able to work with. I'm going to run the code cell, and after it's done, let's refresh the workspace view. We can immediately see the new cleansed campaign table appear as a new table in the marketing lakehouse. Now that I'm done making my changes, I can choose to publish my updated notebook to Fabric. Navigating back to the notebook, let's refresh the browser, and we can see the new table appear in our lakehouse editor, whilst the notebook has been updated with the latest code changes. In Fabric, we strive to give data developers the flexibility to work in any tool that meets their needs, whether it's our notebooks, VS Code, or a completely external IDE.
So before we wrap up, I just want to touch upon how the data engineering workload is deeply integrated into the Fabric platform. So as we know, with Microsoft Fabric, we have this intelligent data foundation. And as part of this unified platform, we unify things like the data lake, or CI/CD, monitoring hub, data hub, and so on. And so we're going to take a look at how data engineering is integrated with a couple of key components. Firstly, from an enterprise information management perspective, we already talked about how the lakehouse is deeply integrated into the One Lake Data Hub along with all the data artifacts in Microsoft Fabric. And what I can do over here is I can even jump into things like the lineage view. I can trace the lineage between my lakehouses, my different notebooks and data sets and reports to see how all of these different artifacts compose together. I can apply sensitivity labels to my different artifacts, marking things, for example, as highly confidential. I can endorse and promote artifacts, and all the building blocks exist already. So what you'll see in the coming months is just us refining these experiences and making them work better together. Now we know CI/CD is a key experience for our data engineers. So we're hard at work to ensure that all of the different data engineering artifacts we talked about today are deeply integrated into both the Git integration in the workspace and also the deployment pipeline experience, so you can deploy your different artifacts between your dev, test, and prod workspaces, either using the UI, or we can automate that via Azure pipelines. So we already have the notebooks in private preview with a Git integration, and stay tuned as these things come to the Fabric public preview. Now, another component that's also super important for our users is, of course, monitoring. You want to monitor all the different Spark jobs that are running. So the monitoring hub, which already is part of public preview, serves as a centralized portal for being able to see all of your different Spark applications. So you kind of have the high-level view where you can see the central view for things like your, let's say, notebooks, but also your data flows and pipelines and all the other artifacts that might be there. But we also have the detailed view where you can jump into the specifics of your Spark application, and you can even jump into things like the Spark UI and history server with native open source capabilities, depending on how you want to track and monitor and debug your Spark applications. We are, of course, also part of a capacity metrics reporting app, so you have that tenant-wide visibility into capacity usage for your Spark workload, along with all your other workloads in a single place, so you can identify resource and usage trends across, your lakehouses, your notebooks, your Spark job definitions, and be able to see how that capacity utilization looks like. And we're also hard at work on the Fabric SDK so that our users can basically automate all of their different processes. We know that a lot of users want to be able to do things programmatically. This includes CRUD operations for your Lakehouse, Notebooks, Spark Jobs environments, execution of code artifacts, managing the compute, your Spark monitoring, and also includes the Libby endpoint for being able to programmatically do that kind of batch job submission. So this is all capabilities that are coming soon. We're working hard on to ensure that you can leverage Fabric in a fully automated programmatic way if you choose to do so. Okay, so that was a little bit of a brief overview of how data engineering is tightly integrated into Fabric, and we're wrapping up the session now. So thank you so much for your time. I hope this session gave you a bit of an overview of how you can think about data engineering in Fabric, how all of these different experiences come together, how you can use lakehouses and Spark. Really looking forward to hearing back from you, hearing your feedback, your thoughts. Always feel free to reach out to me and share, what you think is going well, what we could be improving, and stay tuned for a lot more exciting updates in the coming months. Thank you so much.